These problems deal with the universal form of potential energy gravity. So in this first problem, we are trying to figure out how much speed we need to give our object as it leaves this Kuiper belt object to reach a certain height above the surface and then stop. So the way we do this is rather simple. We take the two locations that we want our object, one on the surface, second at its maximum height. This is our altitude we're going to get to. And what we do is we find the potential energy gravity for that object in each of those locations. We can't use our localized version of potential energy gravity because we're moving too far away from the surface of the planet. So we use our universal form. We're going to calculate this value twice, once on the surface and once at our new altitude. Remember that the value that you get for potential energy gravity with this formula is not the important thing. The important thing is the change in the potential energy gravity. It's that change in potential energy gravity that's going to come from the kinetic energy that we give our object. So we give our object a certain kinetic energy to start with. As it goes up, it's going to slow down because of gravity. When it reaches its highest point, it's going to be at rest, so it will have no more kinetic energy gravity. All of that lost kinetic energy will have gone into changing our potential energy gravity. So we set the two equal to each other, and we solve for the initial speed. It doesn't give you the mass of the planet, so in order to use the equation, we have to realize that we have a formula for volume of a sphere. And once we get the volume of the planet, we use the density to find the mass. So this should be enough information for you to complete this problem. Okay, if it asks you for the escape velocity, we do the exact same procedure that we just did, but now we take that finishing location and we put it so far away from our planet that in essence, the object will never return to our planet. So when we do our potential energy gravity twice, in one of the examples, the distance will be so large that when we divide by such a large number, this potential energy gravity will be zero. So in essence, all we do is find the potential energy gravity on the surface, and we set it equal to the kinetic energy at the surface. Okay, because this potential energy gravity on the surface will actually be the change in energy, since it's going to end with no potential energy. And the kinetic energy is where this change in potential energy gravity came from. So then we just solve for the velocity, and that velocity will be our escape velocity. That is the speed that we need to have to reach a point so far away that the object will never return back to its original location.